Hi, welcome to all to the another tutorial of Etabs 2015, and in this tutorial we will learn about pushover analysis according to IS standards. In previous tutorial we have seen about time history analysis according to IS standards and how to design and analyze a building using response spectrum and other analysis procedures we have already seen. So if you have not seen that tutorials and don't know how to design a building, please check the link in the description and you can follow the link in the video after this tutorial. So let's start to learn about pushover analysis using IS standards in ETABS 2015. So before starting the pushover analysis, we must know what is pushover analysis. So the pushover analysis procedure is about the use of nonlinear static analysis, pushover analysis, okay, come into practice in 1970s. So these all things you can read about pushover analysis in Mario Paz books of dynamics of structures or Anil K. Chopra. So you should follow these two books to study about this pushover analysis. Most of the terms used in the pushover analysis are nothing but the FEMA, that is Federal Emergency Management Agency. These provides the uh, technically sound and national acceptance guidelines for the seismic rehabilitation of buildings. So FEMA 356 provides these guidelines for the pushover analysis and uh, these guidelines tool for the design professional for carrying out the design and analysis of the building. Also the ATC, that is Applied Technology Council, okay, it will provide the procedures for the concrete buildings and most type of the buildings it is applicable for. Using these two core codal provision we can start our pushover analysis. But there are two types of pushover analysis, that is capacity spectrum method and displacement coefficient method. In this tutorial we will go to learn about displacement coefficient method. The capacity spectrum method is a nonlinear static analysis procedure which provides a graphical representation of the expected seismic performance of the structure by intersecting the structure's capacity spectrum with the response spectrum demand spectrum of this earthquake. The intersection point is called the performance point, and the displacement coordinate dp of the performance point is estimated uh, displacement demand on the structure of the specified level of the seismic hazard. So these are the tough uh, description of capacity spectrum method. So if you want to know about all these details, so please go through the books, or I will provide a link as far as possible in the comments. You can see I will provide the links in the description for these all of these definitions of performance points and capacity spectrum, all these things, and what is demand, what is capacity. So these are the things you should know about. So what is capacity, what is capacity curve, what is capacity spectrum, and what are the demand, okay, demand spectrum, to know about the plastic hinges. So why it is required for plastic hinges in the uh, pushover analysis, because we are going to apply a unit load or unit deformation to the building uh, according to the capacity or the displacement coefficient method respectively. So according to these two methods we can perform analysis of pushover. So we will do displacement coefficient method in this tutorial. So let us know about few things about the displacement coefficient. The displacement coefficient method is a non-linear static analysis procedure which provides a numerical process for estimating the displacement demand on the structure by using a bilinear representation of the capacity curve and a series of modification factors or coefficients to calculate a target displacement. The point on the capacity curve at the target displacement is equivalent of the performance point in the capacity spectrum method. So whatever the performance points we are getting in the capacity spectrum method, if we are using capacity spectrum method, that is unit force application is done to the structure, then we will get the performance points. So this the point of capacity curve at the target displacement, the target displacement what we will get from the displacement coefficient method will be equivalent to the performance point of the capacity spectrum method. So these two are interrelated by one or the other. So we will get the target displacement at last in our pushover analysis. So today let's start with the pushover analysis using displacement coefficient method. So let us see the procedure or the steps to be followed. Steps to be followed are we have to model we have already modeled the structure, and we have to do the static analysis. For that we have to design the structure, then we have to go for the pushover analysis. So these three steps are already over for our structure. If you have not seen my previous episode, that is previous tutorial of Etabs 2015, please go through the playlist of Etabs 2015 using IS code in my channel. So let's start with the fourth step, that is pushover analysis procedure. So steps for pushover analysis procedure, all these things are mentioned in this file. This file link I will provide you in the description. That is also you can see and you can follow the steps. So and the steps of what we should follow in the analysis procedure for pushover analysis, that is you can see how to create a model and how to provide a nonlinear static load case. Then we have to run the analysis, and finally what are the results we should see in the pushover analysis. These will be mentioned in the link after the video is uploaded. I will give in the description in within 24 hours. So these are the links, these are the definitions of the things and the procedure steps you should follow during the pushover analysis. So let's start our Etabs 2015. Our model is already ready with 4 panels in x direction and 4 panels in y direction, with 5 columns in x direction and 5 columns in y direction, and it is a square building with square columns, and it's of 5 floors. So let's start. The first step to do pushover analysis is we have to define load patterns. So I'm going to do in that is push x and push y separately, such that we can get analysis result in a proper way, our required direction. The first step is define load patterns. Go to define, then load patterns. We have already mentioned few of the load patterns before using IS standard. So these load patterns are not at all required now, just dead load and live load will be enough, and we can modify or delete these load cases. So our this model is already analyzed with the time history, so we have to unlock the model first. So let us unlock the model. Okay, now we can make the changes to the structure and we can define the load patterns. So in define load cases, provide the name as pushx for x direction and in this provide other type. In type you have to provide other, and you add this new load case and mention push y and add another new load case, that is push x and push y. Okay, we have mentioned the two load cases, that is push x and push y in the other. Then press OK. Now go to the next step. So step 2, we will define the load cases in pushover analysis. Go to load cases and change the push x to by modify showcase to nonlinear static and select mass source as mass source 1, what we have kept. We are not taking any initial condition. Convert this to acceleration because we are considering the earthquake effects, so acceleration we are taking because of nonlinearity, and the scale factor will keep it as 1. So other parameters, modal load cases, will keep it as modal itself, and geometry nonlinearity option will not give any p delta analysis. Now the load application, you can go to modify and select this as displacement control, then use monitor displacement. Then monitor displacement you can change to any magnitude of the load, that is load to be monitored. Up to what load you want to monitor you can change it. So no change we are doing till whatever it is mentioned we are keeping itself same. Then press OK. So result saved will be multiple states, then press OK. We have selected multiple states and the displacement control for these two parameters we have changed, and remaining things are same in the other parameters case here. So after this press OK. Similarly we will change the push y, modify it, go to nonlinear static for pushover analysis, select the mass source as mass source 1, change this acceleration, load applied to load type to acceleration, and for y direction select this as uy, and scale factor is being 1. The modal load case, in other parameters we will change the load application to displacement control. We'll keep the all parameters same, and results save will be multiple states, and press OK. Press OK again. So we have set the load cases. Now press OK to exit this pop-up. Now we have to select all beams to assign the frame hinges to the beams. So we have to apply hinges so that we can study the plastic rotation of the building, and we can know what are the properties of the response of the building using pushover analysis. By going to select, you select the section properties, frame sections. In this select the beams and press on select. The beams will be selected. Go to assign, frame, then go to hinges. So as I said, we will provide auto hinges. The type will be auto. Please note down the steps because these are very necessary steps for providing the hinges here. This is very necessary step for pushover analysis. So we have to provide hinge at one end of the beam and other end of the beam. So each beam will be having two hinges, that is at the rear end and at the farther end. So both two ends will be having the hinges just beside the joint. So we will keep a 5 mm gap between the joint and the, or 5 centimeter gap we will place before the joint for each hinge distance from the joint on the beam, and similarly on the columns. So we will provide auto hinge. The relative distance we will keep as 0.05 at as this side. We will providing here. So at the near end we are keeping at 0.05 meters, that is 5 centimeter I think. Yeah, 5 centimeter. Press on add. Then it will open a hinge table case. In this you can select ASC 4113 and select the hinge table as for concrete beams flexure item. Because we are going for beam, we have selected concrete beams here. The degree of freedom will be M3 because beam is in flexural member, it has M3 moment, and the V value will be from push X, what we have defined as our nonlinear static case, or we can provide any user value what is required to the hinge if you have any other values. But as for the pushover case, we are defining this to be case as push X. Press OK. Now this one joint has been created. Now create the next joint at the farther distance from this end, that is 0.95, and press add. Similarly change this to concrete beams ASC 4113 and M3, and this is push X. All being same, press OK. So for push X we have provided the beam with two hinges, that is 0.05 and 0.95. Similarly we can add for push Y. So there will be two hinges for push X and two hinges for push Y. So we will generate another auto hinge for 0.05 distance, and we will add this. In this time, everything that is it is concrete beam M3 and ASC 4113 is the auto hinge type, and we are just changing to push Y and press OK. Similarly, change the distance of the auto hinge to 0.95. Press add, and this time it is already we have changed to push Y, so add plus OK. So we have for push X 0.05 auto hinge M3, it is beam auto hinge, and for 0.95 we have another beam auto hinge for push X, then for push Y, and this is also for push Y. To confirm these properties, you can see here the auto hinge data what we have provided. So after that you can press OK. Since we have selected the beams, all the beams will get its auto hinges connected at every distance of 0.05 from the corner of the joint of different beams. So each beam is having similar 0.05 distance from the end of the beam. As you can see now, we have assigned the hinges to beams. Similarly, we have to assign the hinges to column. Similarly, go to the select option and select the properties of frame sections, this time the columns. Select, see that the columns are getting selected from top to bottom. Now go to assign frame hinges. Now select the auto hinge and similarly provide the distance 0.05 and press add. This time we will select it as ASC 4113 or FEMA 356. So ASC 4113, we have the property here. For bracing we can select this one. For this columns it is okay. So now here we will select the concrete columns because this is RC building. So in this we will select for column load, shear and moment all together. This P M2 M3 is the degree of freedom for the concrete column. Now the case combination we will take it as push X first. So push X is the case combination. The condition will be the flexure shear and all the things remaining the same. Press OK. Similarly, add another at 0.95 as a concrete column and push X P M2 M3 hinge. Press OK. So two hinges are added in the push X direction. For push Y direction, again take 0.05 distance and add. This time change this to push Y and press OK. Similarly, at the distance of 0.95, add in the push Y direction, press OK. So we have added to the column bottom and top two hinges in X push X direction and 2 hinges for push Y direction. So you can check all the hinges by clicking this option here. Then press OK to confirm the hinges. The hinges got assigned. You can see by going to the elevation view in this diagram. You can see that the columns have also got the hinges at, that is 95% 5% distance from the bottom and 95% distance from the bottom, that is at the top 5% distance. So we have provided the hinges to the columns and the beams. Now it's time for doing analysis. Go to Analyze and set the load cases to run. This time we will not run the earthquake case and the wind cases, and also response spectrum and time history what we have already did in the previous tutorials. Will not run these cases. So select these cases and set to do not run. Only we will run the dead load, live load and pushover. We will not run the modal case also. So we will run only dead, live and the push X and push Y load cases. So set all the other cases to do not run and press on run now. Pushover analysis will take longer time than the time history analysis. So this may take some time according to your data, that is building height and building members. So this might take as long as 20 to 30 minutes for small height of buildings and 1 to 2 hours for large buildings and tall buildings. So this is very lengthy procedure because one by one it will unload and load the program. So you can check the details by clicking on show details button and it will show the analysis going on at the background during running this pushover analysis. So as far as the analysis is going on, I want to say you one thing, that is, if you have any questions about Etabs 2015 or how to analyze, design and any other doubts in Etabs, you can ask your questions in the comment section below. So sign in and comment below and do not forget to subscribe my channel, and further you can go to discussions section after subscribing my channel. Inside the discussion you can comment and you can ask me personally questions if you don't want to ask in the video below, so you can directly ask me there. All the pushover analysis and time history analysis and all the procedures links I have provided in the description below, and moreover the definitions I will be providing in the comments below. So do read the comments to know more about the definitions of the terminology used in the pushover analysis. So after the analysis completes, we can see the deformed shape due to the dead load. And after clicking this next button at the bottom screen, we can go to the live load. Then for push X, you can see the hinge formations here. Okay, for push X, there are 9 steps. So the 9 performance points we are getting. Each step is having differential loading. First at the green zone, it is between B to C zone and C to D and D to E. E is a breaking point of the hinge. So at E, the building will collapse. B to C is the green zone if you see the hinge diagram. So in the push X direction, we can see step 1 to 9. So in step 1, it has the two hinges formation here in the green color. So green color means it is between B to C. So if you see the curve, that is from B to C, it is in the safe zone, and after C, C to D, it is strain hardening point, and D to E, it is a collapse line. So after E, it is a breaking point, so the structure will collapse. IO is immediate occupancy level, LS is the life safety level, and CP is the collapse prevention level. So the hinge forms from B to C region. A to B, the hinge is within the limit states. So it will not form a hinge in A to B. The plastic hinge formation takes place after B to C point in the B to C zone. In C to D, the strain hardening takes place, and from D to E, it will not take any further force, and it will go to the breaking point, and the collapse will take place at point E. So these ranges has been set up in the in this color zone here. It is shown B to C in green color, C to D in blue color, light blue color, D to E in magenta color, and E to the end, that is breaking cracking point, in the breaking point in the red color. So first two hinges forms at the step 1 of push X direction, and you can see the two hinges forms are in green color, that is in the safety zone. There is still the hinge formation takes place, but the structure is still standing, so it has not get collapsed, and you can see the displacement in the UX direction, that is 11 mm, and all other directions it has very least deflection. So these are the displacement you can read out from here, or you can see the table. So go to the next step, it is step 2. By clicking on this, you can see in the step 2 more hinges have formed from bottom level to the top story level, and on this side few hinges have formed in the beam zones also. So the column at the bottom level to top level in the X direction has been formed. For the push X load in the Y direction, the hinges are formed in the beam. You can see. Go to the next step. Further, you can see more hinges are forming, developing from the bottom to the top. Now the hinges are developing in the beams first, so the beams are getting uh, towards the plastic zone now. And the bottom column members are already got the hinges. So until we get the red color or the magenta color, we should continue with the steps to see whether the building is failing. So you can see more the number of hinges formed, the more the occurrence of deflection. Step 6, step 7, step 8, and step 9. So until the 9 steps have formed during this, We cannot see any failure point. All the building hinges have not formed still during the step 9 also in push X direction. Now we'll check for the push Y direction now. Step 0. It has 14 steps amazingly. You can watch this one by one, and you can read out the displacement by taking out your pointer on the points wherever you want to read the deflections or the displacements. Like this you can go on checking the results up to the 14th steps. Moreover, you can go to the display button here and you can check the energy and the virtual work diagram and also the hinge results here, and the static pushover curves where you can find the capacity curves and the demand curves. Change the curve type to FEMA 440 and select push X for push X direction curves. The legend type you take it as standalone. Select the curve plot axis as SANT versus time. Family spectrum, press on yes, and it will now show the different capacity curve here and the single demand curve here, and the demand family lines you can see that it is intersecting the single demand curves. Now go to display and show hinge results. So you can watch here after clicking on the hinge results display in the display option, you can see by step the variation in the hinge points. In show tables option from the display, you can now see the pushover results for story, maximum and average displacements. You can find the displacements due to push X minimum. The values for push X and push Y you can copy from here for your structure. And you can also see the story drifts in X and Y direction due to push X and push Y, and also the story forces. You can also check the base reactions due to push X and push Y. So this concludes the pushover analysis of Etabs 2015 of RC building using IS code. In next tutorial, we will see about the different methods comparison or the different types of models of buildings, whatever the frame systems and more things we can see in the next tutorial. So comment below whatever you want first me to create a tutorial for you so that you will be beneficial from me for guiding you to the most extreme level. Thank you so much for watching this video. Do subscribe and share with your friends. Thank you. Bye.